So let's do this question, which is a container with most water. So in this question, it is a very simple problem. Basically, we are given with an array which represents the vertical length of lines that will be holding some water, and we need to use only two lines, and we need to calculate the maximum amount of water that can be stored. Uh, the basically width of these lines are negligible, so we don't need to consider them, and distance between two lines is we can suppose it to be 1. So simply like this, we need to calculate the maximum amount of water that can be stored. So for this, we can refer to this graph. For example, the given array is 3 1 2 and 3 1 2 4 and 5, and suppose that this is the graphical representation of this array, right? So now suppose that if we want to choose these two lines, like the 0th one and first, so we can store only this much water, like 1 unit, and one will be the length and one will be the breadth. Although one of the length of one of the lines is 3, but still we can hold only the minimum of length of both of these lines, right? So for example, if we want to use this particular line and this particular line, so we will be able to store only 2 into 2, that is 4 units of water in this, because although the length of this line is 4, still we will be able to hold this much of water only, because it can support only this much water. The rest will overflow, and that we don't need to consider that. Okay, so in that way, we need to calculate the maximum amount of water that can be stored between two lines. So in this question, by seeing this, we can simply say that if we will use this line and this line, then we will be able to calculate the maximum amount of water that can be stored. That will be minimum of this like the vertical line, that is minimum of 3 and 5. That will be uh, minimum of 3 and 5 will be what? 3, and then we will be able to see that the breadth will be calculated, like suppose that this is index j I and this is index j, then we will be able to calculate this. Suppose that this is our I, okay, and this is our j. So uh, if j minus I is basically 0 1 2 3 4, so 4 minus 0 is 4, so the length breadth will be 4 and length will be what? 3. So the area will be 12. Okay, so for this question, we can simply use a two pointer approach, or if that does not comes to your mind directly, then we can think of another solution, that is using two different arrays. First of all, we will calculate the left max array, and then we will calculate the right max array. So in the left maximum array, we will try to store whatever comes to the left of the maximum. So in the left max array, store the first element as it is. In the right max array, store the last element as it is. And then in the for the left max array, calculate the previous of the left max and current of the array. Okay, so which of them is maximum value? So 3 is maximum value. Okay, so basically we are checking which is the left max value of that particular element. For example, for 1, what is the left max value? It will be 3. For 2, what will be the left max value? It will be 3. For 4, what will be the left max value? There's no one greater than 4, so 4 will be itself its left max value. Okay, and then for 5, 5 will be its less left max value, because others are smaller than it. Okay, so for comparison, what we are doing, first we will store the first element as it is, and then we will compare them like this. Okay, whichever of them is will be larger, we will store that. And for the right max array, similarly, we will copy the last element as it is, and then we will compare them, these parts. In that way, we will be having our left max array and the right max array. Now we will use two pointer approach. Point your I at this place, basically 0, and point your j at n minus 1, that is last index, and then calculate the minimum height. Okay, so what was the minimum height? Whatever value is less of these lines. Okay, for example, if we were using a line of length 3 and a line of length 5, so it was able to store only 3 length. Okay, so that's what we are doing here. We will store the minimum length, that will be 3, and uh, 3 will be our length, and what will be the breadth will be j minus I, that will be what, 4. Okay, so 3 into 4 will be our area, that is 12. Now this is the two pointer approach. In this question we got our answer in the first iteration only, that will be the maximum area, but still we don't know. There are possibilities that we can find out, I mean, in not in this question but in another question. Okay, so that's why we will use the iteration multiple times, and now we will see that which of them is greater, like 3 or 5, which of them, like array of I is greater, or array of j is greater. So we can see that array of uh, j is greater, right? So we need to increase the height of I. Okay, we need to increase the I part so that we can increase the area, because we don't know that whether we have got the exact answer or not. Okay, so now we will increase the I pointer. Now I will reach here, and now we will do the same calculation. What will be the maximum height? The maximum height will be either 3 or 5. Okay, and we will get the same thing, do the same thing again and again, and this is the code here. So we will calculate the left max array, then we will calculate the right max array, then we will use the two pointer approach. We will calculate the height by seeing the minimum of left max array of I and right max array of j, and then we will calculate the width by simply calculating j minus I. We can obviously use absolute here as well, and then we will calculate the maximum area, the current area, maximum of the maximum area and the current area, and then we will basically see whether to increase I or to decrease j according to the condition. If array of I is less than array of j, then we will increase the I pointer, otherwise we will increase the j pointer, and then similarly we will get our result. Now this solution will take time complexity of n, and space complexity of n, and if you can, if you are able to see this, then we are not as much using this left array and right array part. So we can simply do it by seeing this simple array as well. So suppose that we are using the I pointer and j pointer here only. Okay, this is our I pointer and this is our j pointer. Okay, this is our I pointer and this is our j pointer. So we can see that we if we apply the same logic here, then minimum of I and j, and then for breadth we calculate j minus I, we will still get the same answer. So that's why we are doing we are basically using the simple two pointer approach. We are having I at 0 and j at n, and then we are having this simple maximum is equals to 0 to store the maximum area, and then we are using the two pointer approach while I is less than j. Then we are calculating the area by using the minimum of area of I and j into this part represents basically the base part, that is j minus I. Then we are calculating the maximum area. We are again using the same condition. If area of I is less than area of j, then we will increase the I pointer, otherwise we will decrease the j pointer, and then we will return whatever maximum area we have got. In this case, as we are not using any extra space, so that's why we are getting space complexity as O of 1. So that's a better solution. uh, okay.